Hey everyone, Matt from Workshop Tinkers here. So, as you can tell, I've replaced most electronics in my 101 Hero. If you can't tell, those of you who don't have your own Hero, let's zoom in. This printing speed is 30 millimeters a second. Just over twice as fast as the fastest the Hero can print normally. Now I'm waiting to see if it has problems because I'm still tuning it. I just had to skip a little bit ago. So what I've done is I've replaced the old steppers with NEMA 14 steppers. I've replaced the hot end with this is an E3D V6 Lite hot end. It's a little bit more pricey than a knockoff, whatever, J-head, whatever you want. The original print head probably would have worked, but I didn't want to have to figure it out, and this is more precise anyways. It is on a bowden setup. There is a, if you can see, stepper motor in the back there, right there, that is actually doing the extrusion for the hot end here. And it is all running, bring it back out, on that board right here. That is a Ramps 1.4 with an Arduino, and I have a spare Arduino. I've burnt out one or the other of these. I need to do more tests, figure out exactly what I've done, but neither of these worked right. I replaced it with another spare I had. Boom, working. This is running the firmware on the 101 user forums that I really should have looked up the guy's name before starting this video who did it. It is, hold on one second. Hold on. Hold on. Crap. You know what? I know where it's at. I will have to post a link. I can't find it right now. Oh, Digital Whitewater is the guy who configured it. The only thing I had changed was he had the logic for the end stops backwards and two of the measurements backwards. So if you're members of the forums, I will post the fix on there as well, what I found. Obviously it's working quite well. It's already on to the fourth or fifth, I think it's the fourth layer there, since there's three solid and then it starts filling in with fill there, which is what you're seeing. It's over twice as fast, and as this is my first print, we'll see what the look of it is, but it's already so much better. So before I'm going to say this is done, I am still getting skips. That is where the speed of the stepper overcomes the tension of the timing belts. Now these timing belts use just spring tension, which adds in slop and adds in other irregularities. What I am hoping once this print is done, I am going to next up here, let me move the camera again, sorry. There we go. Okay. These bearings here, I want to remove this bearing here on all three sides. I want to make a bracket that uses these two screws here and then the support of the legs itself as a bracket, and then an adjustable tensioner here. There's a lot of them out there. Whether or not I can use the existing bearings or if I have to use actual bearings. I have my own, so it doesn't really hurt me to use different bearings. I'm just trying to make it as usable for everyone else without buying a bunch of stuff. But thankfully bearings are cheap. Really cheap. The stepper, the timing belt bearings. So once this print is done, I'm going to take off one of the springs and see how much higher up the end of the timing belt is going to go, and I will start working on a bracket of some way, shape, or form. That will do a couple of things. I believe it'll increase the tension on the belt enough so it's not even finger tight. I mean, if I press any harder, I'll really disrupt the print, and I want to see this print finish. But it should help keep the skipping down and really maximize the utility of this frame, because the frame is the most expensive part of one of these prints, more than likely. It's also most difficult, and I'm not good at math and figuring all this stuff out. What is already been done for me is making sure the physical sizes will work. If I had gotten the printer as it is now with the NEMA 14s without those geared steppers, I probably would be very happy with it right off the bat. It would have probably added $30 to the cost. A little bit of height, and actually my printer isn't even sitting flat right now. It's on an angle, but it's printing just fine. Yeah, it's sitting on a screw right now. But I'll move you guys back so you can continue watching it for a minute while I chatter at you. It's going pretty quick. This is just a benchy, of course. If I had gotten this for $100, which is $30 more than I originally paid for it, because I got the $70 Indiegogo campaign, I would have been really happy. I had to spend the extra $30 plus the... So I want to say how I have it with the real extra large power supply is $45, $70. I have about $100 of extra parts here. I could get it down if I wanted it to if I really looked. I think I can get the NEMA 14 for $10 a piece, the ramp board, Arduino, and the drivers for $20. I know that's for sure. And then a 5 amp 12 volt power supply should be plenty for this setup. It's not using that much power, I don't believe. I will do the calculations, but the hot end's a 30 watt power supply, and then it's 4 NEMA 14 motors, steppers. I'll do the calculations and see what the maximum power draw is, but I think 5 amp would be plenty instead of this big 20 amp 12 volt power supply, which is enough to drive multiple extruders and 5 steppers and all that kind of fun stuff. So, all in all, if anybody's really disappointed with this printer, these parts that I'm making is printable on this printer. You might want to print them, get it working, print them again, and be done, because increasing the quality will only help. But I'll keep working on it, see how good I can make it. Anyways, thanks everyone so much for watching, and see you next time. Keep tinkering.